Think math.
Last time, we said a logarithm hugs the vertical axis and plunges down beside it. But look at this graph. The cliff has exactly the same shape, yet it stands somewhere else, shifted to the right. So the cliff was never nailed to the vertical axis. Let us look again at where the cliff comes from. A logarithm plunges without end as the number inside it approaches 0. So the cliff always stands exactly where that number hits 0. In the plain version, the number inside is just x, so the cliff sits where x is 0. That is the only reason it was the vertical axis. Now change the inside to x minus 2. It hits 0 where x is 2, so the whole cliff slides 2 steps to the right. The domain follows it. The inside has to stay positive, so x must be greater than 2. The cliff and the edge of the domain always sit at the very same place. This time, add 3 to the whole logarithm instead. The graph lifts 3 steps upward, but the cliff does not budge because the inside was never touched. Change what is inside and the cliff moves sideways. Add something outside and only the graph moves up or down. The same thing happens in the exponential, its mirror. An exponential has a flat cliff, a horizontal asymptote, and adding 3 on the outside lifts that asymptote up to a height of 3. The exponential's asymptote moves up and down, the logarithm's moves left and right. Same story with the directions swapped. So here is the summary. The cliff of a logarithm stands where the number inside hits 0. Change that number to x minus 2, and the cliff and the domain both slide 2 steps right. Add 3 on the outside, and only the graph rises while the cliff stays put. Do not memorize the picture. Find the place where the inside hits 0, and that place is always the cliff. A sip of math every day, here at Think Math.